Presently, President Biden has presented the first picture to be shown freely from the James Webb Telescope, the biggest and generally strong at any point sent off into space. The tremendousness of the inestimable Webb has done everything except upset our quest for information in the field of astronomy. What's more, planetary examinations it has constrained mankind to set up modern space telescopes and send tests to investigate the far-off heavenly peculiarity in this pursuit. We have revealed fresh, clear pictures of Proxima B, an exoplanet, moving in the gravitational support of Proxima Centauri. Its disclosure in 2016 opened new aspects in cosmic investigation, and presently the most clear picture of Proxima B delivered by the James Webb Telescope is here. It is nothing to joke about. Stick with us to see the reason why it is important to such an extent. Proxima Centauri is the nearest known star to the Sun, found in 1915 by the Scottish cosmologist Robert Innes. He distinguished this red small star as the nearest individual from the Alpha Centauri star framework. A century after the fact, in 2016, an global group of stargazers drove by GM and Happy Salvage found Proxima B, a divine body circling Proxima Centauri, arranged inside the tenable zone of its star. This exoplanet ignited energy upon its disclosure, promising a likely look into the cosmology of tenable universes past our sun-powered framework. Divulged from the perspective of the James Webb Space Telescope, the meaning of Proxima B reaches out far past its divine presence, offering a enticing port opportunity to investigate the secrets of far-off universes. The disclosure of Proxima B was a turning point in astronomy, regardless of its closeness. Innovative limits had thwarted definite investigation until the new advancement, outfitted with forefront imaging and spectroscopic devices, the James Webb Space Telescope has now offered stargazers the very first direct picture of this world estimated exoplanet. The picture is nothing to joke about. It has not just extended how we might interpret adjoining divine bodies, yet, in addition, ignited significant ramifications for logical investigation past our sunlight-based framework. This picture addresses a urgent accomplishment, offering a visual understanding into an exoplanet dwelling inside the livable zone of a close-by star. This advancement has powered fervor inside mainstream researchers, restoring the journey to appreciate the potential livability of exoplanets and investigate the possibilities of life past our sun-powered framework. So how was the James Webb Space Telescope ready to help us here? Position at the subsequent slack reach point, or L2, around 1.5 million kilometers, around 1 million miles from Earth. The JWST is the zenith of our space age developments. This area permits it to keep a steady circle comparative with our planet as it rotates around the Sun. Furnished with a variety of cutting-edge logical instruments, the JWST can catch pictures and gather information across different frequencies, particularly in the infrared reach. Its essential mirror is made out of 18 hexagonal portions and has a breadth of 6.5 m, 21 feet, fundamentally bigger than those of its ancestors. To picture exoplanets like Proxima B, the JWST uses its close infrared camera NorthCam and close to infrared spectrograph NSpeak, among other instruments. The NCam is essential for imaging and recognizing objects in the close to infrared range, while NPC performs spectroscopy to examine the compound synthesis, temperature, and different properties of divine bodies. Given Proxima B's distance from Earth and the difficulties of noticing exoplanets, the JWST capacities are fundamental. Its infrared responsiveness permits it to recognize the faint infrared light produced by Proxima B, which is pivotal for portraying the planet, concentrating on its climate and possibly recognizing indications of livability. The telescope's high goal and awareness empower it to accumulate definite data about exoplanet like Proxima B, contributing essentially to how we might interpret these far-off universes and its far coming. The JWST was gone before by the Hubble Space Telescope HST, which stands as a symbol in space investigation. Sent off in 1990, the HST denoted a huge jump in our comprehension of the universe. Its process follows back to the space race period of the 1950s and 1960s, a period portrayed by serious rivalry between the U.S. also the Soviet Association. This competition stretched out past international contentions, also into the domains of science and innovation, finishing in aggressive space programs. The starting points of the Hubble can be followed to the consequence of the space race as space offices tried to rise above the bounds of Earth's air, which mutilates and hinders a significant part of the approaching light from divine objects. NASA's reaction to the issue was straightforward. They imagined a space-based observatory that would sidestep these barometrical restrictions, furthermore offer remarkable lucidity and accuracy in cosmic perceptions. Anyway, upon its send-off, a flaw in the Hubble's essential mirror undermined its underlying capacities. The mirror experienced circular deviation, making pictures be obscured. This decreased the telescope's adequacy altogether and prompted a significant reassessment of the task, requiring a fix mission in 1993, where space explorers introduced restorative optics to redress the mirror's flaw. Notwithstanding this early misfortune, the Hubble happened to reform how we might interpret the universe. It directed broad reviews, counting the Hubble profound field and the ultra-profound field, catching pictures of inconceivably far-off universes, shedding light on the early universes. Advancement. The HST additionally gave point-by-point pictures of planets inside our sun-based framework, permitting researchers to study their environments, atmospheric conditions, and moons. The Hubble likewise noticed heavenly birth, advancement, and demise, uncovering unpredictable subtleties of star framing, districts, and planetary nebulae. Its perceptions added to estimating the pace of extension of the universe, prompting the revelation of dull energy, a mysterious power driving the universe's sped-up development. Anyway, while progressive, the Hubble had restrictions. Its instruments, despite the fact that weighty at the time, depended on innovation from the 1970s and 1980s. Additionally, its area in low Earth circle didn't safeguard it totally from the planet's air unsettling influences, normally the requirement for a replacement. The James Webb Space Telescope originated from the longing to survive these constraints. The JWST was planned with bigger and further developed instruments, explicitly enhanced for infrared perceptions, empowering it to peer further into space, concentrate on the earliest cosmic systems. What's more, describe exoplanets in manners the Hubble just couldn't. The JWST in this manner addresses another period in space investigation, expanding upon the tradition of the Hubble while pushing the limits of how we might interpret the universe. The JWST has given us extraordinary lucidity in cosmology and the investigation of exoplanets, like Proxima B. Proxima B's circle around this parent star Proxima Centauri is a spellbinding part of its attributes, notwithstanding the family member closeness to the red small star. This exoplate exists inside the tenable zone, a locale where conditions may take into account the presence of fluid water. Its area in this zone doesn't reflect Earth's anyway. Proxima B gets a fundamentally unique energy consumption. Contrasted with our planet, this variety in energy assimilation emphatically impacts its environment, surface conditions, and generally tenability, the possible impacts of this energy fluctuation, whether it prompts outrageous temperature variances or special environmental pieces present. Charming roads for additional examination. What's more, understanding Proxima B lives inside tempting Re at simply 4.2 light years away, notwithstanding being Earth-sized and possibly tenable, it remained subtle in light of the fact that no telescope ground-based, or on the other hand in space, has the ability to straightforwardly photo this far-off world. The JWST is planned definitively for infrared perceptions and hence doesn't need to catch the planet outwardly. Rather, it's zeroed in on unambiguous infrared frequencies following the variety changes of Proxima B as it circled. This is a promising examination region, and we have taken numerous intense steps since the exoplanet's disclosure in 2016. What really recognizes Proxima B is its short orbital period. The exoplanet finishes a full insurgency around Proxima Centauri in a simple 11.2 Earth days. This brief year raises convincing inquiries concerning the climate and the potential livability of the planet. Such a quick circle recommends that Proxima B likely encounters gravitational and flowing powers altogether different from what we notice and feel here on Earth. These contrasts can shape its topography, weather conditions, and potential for holding in air. Obviously, there's much we need to learn about the planet yet. How did we find it in any case? The disclosure of Proxima B stemmed essentially from the outspread speed strategy, a refined procedure used to distinguish exoplanets by estimating the minute changes in a star range caused by the gravitational pull of a circling planet. To more readily grasp this approach, envision a star and its planets moving together through space. When a planet circles a star, it doesn't simply rotate around it, additionally pulls the star a tad as the two of them move. This pull offward makes a wobble in the star's development that we can distinguish from Earth. Researchers search for minuscule changes in the star's light brought about by this wobble to sort out whether or not there may be planets circling it. We have gone over obvious signs inside the light produced by Proxima Centauri showing the presence of a relative Ly little Proxima B encircle around it. This critical finding drives the investigation of exoplanets to new levels, prodding further examinations concerning Proxima B's barometrical piece surface highlights. Also, potential bio marks figuring out the complexities of this adjoining exoplanet holds the commitment of revealing experiences into the more extensive inquiries of livability and the pervasiveness of life past our sunlight-based framework. The exceptional part of this revelation lies in the way that Proxima B involves the tenable zone of its star, igniting huge excitement inside mainstream researchers. There is a likelihood that this rough planet may house condition reasonable for fluid water, a fundamental element for the development and food of life as we know it. Obviously, the closeness of Proxima B to its parent star Proxima Centauri presents huge difficulties for expected life on this exoplanet. Normally, the planet is exposed to extraordinary radiation from its star. The Radi barrage can possibly change its synthetic arrangement and affect any potential biosphere. Understanding the degree of these impacts requires complicated models that think about the interchange of radiation. Furthermore, the planetary climate, while the planet may have an environment prepared to do supporting fluid water, the closeness to the star could bring about outrageous climate designs, including furious sun-powered breezes. Also, possible air stripping due to the star's movement. These circumstances could prompt a climate definitely unique in relation to Earth, making it trying for life to flourish anyway. Founded on the new information from JWST, we have reasoned that the Planet in all actuality does without a doubt hold water fumes in. Environment. This is nothing to joke about. Water is a fundamental element for tenability. Furthermore, figuring out its presence or non-appearance on this exoplanet is vital. Current logical models and observational apparatuses, including spectroscopy and air displaying, have been utilized to concentrate on Proxima B's climate. Somewhat spectroscopic examination empowers researchers to recognize the creation of gases in the air, giving bits of knowledge into the possible presence of life-supporting components like oxygen, methane, or carbon dioxide. These instruments, joined with high-level environmental demonstrating, offer brief looks into the planet's barometrical conditions and assist us with figuring out theories with respect to its tenability. Further progressions in observational methods and displaying will be instrumental in disentangling the secrets of Proxima B's potential to life. However, the chance of extraterrestrial life in the world, regardless of the difficulties presented by the proximity of its star, is essentially worth engaging. After all, we truly do have genuine world instances of life taking on such challenges even back here on the planet. Extremophiles are inconceivable microorganisms that push the limits of where life can exist. They flourish in probably the most outrageous conditions on Earth, puts that were once thought aloof, like extremely hot springs, profound aqueous vents, acidic lakes, or freezing Antarctic ice. They have opened up additional opportunities for where life could exist past our planet, proposing that conditions recently considered dreadful could uphold life much like the outrageous circumstances on Proxima B may be home to. Extremophiles. Earth has a different cluster of them exhibiting life's versatility to outrageous circumstances. Among them we have thermophiles that twist in high-temperature conditions, for example, canteen seagoing, a bacterium flourishing in underground aquifers, and Pyrolobus fumari found in remote ocean aqueous vents where temperatures surpass 100 degrees. See cryophile. Then again thrive in frigid temperatures. For instance, Pius arcticus can make do in icy and Antarctic conditions. Also acidophils like Acidithiobacillus ferrooxidans flourish in exceptionally acidic conditions, while alkalophiles, for example Natron nominus, furan, make do in profoundly soluble conditions. Last of the pack, halophiles like Halobacterium salinarum live in exceptionally saline conditions like salt pads, exhibiting strength to outrageous salt focuses. Thinking about the potential conditions on Proxima B, where extreme radiation because of closeness to its star may be a test, life forms like extremophiles on Earth might have the option to adjust and maybe even flourish. Earth's Dioc carcass radiodurance, for example, flaunts protection from ionizing radiation, getting through portions large number of times higher than whatever would be deadly to people. Extremophiles have developed different transformation procedures, including DNA fixed systems, defensive shades, and exceptional cell structures. These variations allude to potential endurance components that life structures on Proxima B could create to persevere through its unforgiving conditions. Finding extremophile-like organic entities on Proxima B prepared to do getting through outrageous radiation or other brutal ecological variables would, to be sure, alter how we might interpret life's flexibility past Earth. It could reclassify the limits of tenability and extend the extent of exobiology, showing that life may persevere in apparently threatening extraterrestrial conditions. Yet this is more straightforward said than done. Investigating Proxima B and other far-off exoplanets presents critical mechanical obstructions. At present we are confronting constraints in straightforwardly noticing, what's more, portraying far-off divine bodies, while telescopes like the James Webb Space Telescope offer priceless bits of knowledge. They have requirements in catching itemized pictures or leading on location examination because of huge distances. Furthermore, the impediments of accessible innovation. Conquering these impediments requires headways in telescope, plan sensor innovation, and maybe, indeed, even the improvement of progressive impetus frameworks to empower interstellar missions. Future advances for interstellar missions could upset our ability to investigate and stand exoplanets like Proxima B. Ideas including progressed drive frameworks, for example, sun-oriented cells, particle impetus, or even hypothetical ideas like twist drives are under concentrate on now. These advancements expect to essentially lessen venture out chance to far-off star frameworks, empowering nearer perceptions and possibly even immediate investigation of exoplanets. Anyway, at this point, these ideas are to a great extent hypothetical and require broad exploration and improvement prior to becoming possible for interstellar journeys. The investigation of Proxima B is critical for progressing how we might interpret exoplanets and the potential for life past Earth. Considering this exoplanet and others inside its tenable zone contributes critical information to refine how we might interpret planetary development, livability conditions, and the predominance of life-supporting conditions in the universe. Such information is vital for future space investigation missions, directing the choice of focuses for additional examination and possible human colonization. Asian endeavors. Proxima B is like a venturing stone toward disentangling the secrets of far-off universes and widening the skylines of our comprehension of the universe. The investigation of exoplanets stretches out past Proxima. Exoplanets are classified into different classes, counting gas Goliaths like hot Jupiters,